So let's try some more examples. 2x cubed plus 7x squared plus x minus 10 equals 0. Well, the first thing I'm going to do is make a name for my polynomial. Let p of x equal 2x cubed plus 7x squared plus x minus 10. What I want to do is use the factor theorem. If I can find a number to substitute for x that gives me 0 when I evaluate, then I can use that to give me a factor of this polynomial. And all we have to do is just try a few numbers. 1, -1, 2, -2, and so on. So let's try. Try, p of 1. Well, that's going to be 2 plus 7 plus 1, take 10. Oh look, that's equal to 0. In the kinds of examples we're going to give you, it's going to be one of the first few numbers you try. It's probably not going to be past 3 or 4 because it would just take you too long to guess. In practice, of course, if you really wanted to do this for something that wasn't a canned example, you could use a computer program or a spreadsheet to try to work out what these numbers might be. But if you're doing them by hand, like in an exam, for example, we're going to make them one of the first few numbers you'll try. In this case, positive 1 worked. Good. That means x minus 1 is a factor of my polynomial. So I'm going to divide it. 2x cubed plus 7x squared plus x minus 10 divided by x minus 1. X goes into 2x cubed, 2x squared times x times 2x, so x times 2x squared is 2x cubed. -1 times 2x squared is negative 2x squared. Subtract. Goes away. 7 plus 2 is 9x squared. Bring down the next term. X goes into 9x squared, 9x times. X times 9x is 9x squared. -1 times 9x is negative 9x. Subtract. That goes away. X plus 9 is 10x. Bring down the next term. X goes into 10x 10 times. X times 10 is 10x. -1 times 10 is negative 10. And that goes away exactly as I would expect, because I already knew it was a factor. If I got something here other than a remainder of 0, either this was wrong or my long division was wrong. Okay, I knew x minus 1 was a factor. I've now got the quotient. So write p of x as x minus 1 times 2x squared plus 9x plus 10. Now I have a choice. I can factorise this quadratic, or I can keep looking for factors. I can let q of x equal to this and evaluate q at 1, q at minus 1, q at 2, q at minus 2. Because this is a quadratic, I can probably work it out quicker. Long division is slow. So, I need to work it out as a quadratic, two numbers that multiply to give me 20. Remember, if it's non-monic, you have to include the number at the front, a times c, 20, and add to give me 9. Well, that's going to be 4 and 5. So let's go. X minus 1, split up the middle term, 4x plus 5x plus 10. Now remember, if this is monic, if there's a 1 here, you can just go straight to x plus 4, x plus 5. That will not work for a non-monic. My suggestion to solve non-monic quadratics, always just split this term up with the two numbers you've got and then factorise this. You will find that works better. So, factor out the left is 2x times x plus 2, and factor at the right is 5 times x plus 2. See how easy that is when I do it this way? X minus 1, x plus 2, 2x plus 5. Common factor x plus 2, left with 2x plus 5. All right, my original question said to solve it when it equals 0. So let's do that. 0 equals x minus 1, x plus 2, 2x plus 5. That means one of these factors must be 0. X minus 1 is 0, or x plus 2 is 0, or 2x plus 5 is 0. For simple terms like this, I don't mind if you go straight to the answer. That is, x is 1 or x is negative 2. But if it's a bit more complicated, until you get comfortable with it, write the original before you try to simplify. 2x is negative 5, x must be negative 5 on 2. So we did guess this. We could have guessed this. It would only have taken a couple more guesses. I doubt we would have guessed this. But we could have worked it out by long division of this, by x plus 2, if we wanted to. It's just that a quadratic is actually easier to factorise this way. Of course, if you have trouble factorising that quadratic quickly, you have a couple other strategies. You could complete the square. You could try just trial evaluation with the remainder theorem and see if you get something with 0. You could use the quadratic formula as well. So there's all those options.